In previous class, we have studied what is SVD, and we have seen the theory behind SVD, right? Mathematically, we have calculated SVD. We got what is the definition of it, why do we use it, and what are the each and different terms we have. The three different terms we have: U, sigma, and VT. What are the different terminologies, and what do they even represent in the given pattern? We have understood all of these things. Now, what we are going to do is we are going to implement this concepts, the concepts which we have learned in the last week on Wednesday's class in today's lecture. Okay, so what I'll do is that I'll directly go ahead and first of all tell you about the problem statement, and understanding the problem statement is the most important thing, and this is the first step, the zeroth step of our lecture. So talking about problem statement, right? Imagine that I have Netflix metrics, right? And if you see a typical user, right? If you see Netflix interface, Netflix suggests us movies, right? And this movie recommendations are based on our taste. Whatever we like, automatically out of the blue, we get those sort of recommendation. For example, if I like superhero movies, then my recommendations mostly will be filled with superhero movies. If someone likes Korean drama or Chinese drama or romantic series, that particular thing will appear on their screen. How? And you need to observe that not only that, there's a crossover, right? There is a sci-fi genre, there is a mixture of action and romance. So how are you gonna classify? Like if you show the same movie to user again and again, for example, if I'm watching superhero movie and every time I'm getting superhero recommendation, then I get superhero fatigue. I might not watch it. I'll go to some other platforms. So this recommendation systems has to be very accurate and very dynamic as well. So how are we going to do that? This is the thing we are going to tackle using the concept of SVD. So if you take a typical Netflix user, they might have seen few movies and they might have rated this movies, but let's say there is a movie X which I haven't watched, then for that particular user that movie is unrated. He has not watched it, that's why he did not rated it. So if you imagine the metrics, right? If I talk about the metrics, because the first and foremost thing in SVD is knowing the metrics, knowing A before we even go to our U cross sigma cross VT. Before going to all this, we need to know what is our A. And in this case, this is our Netflix rating table. If you see a Netflix rating table, it looks like something like this. Like we'll have some values 10, 8, blank, 8, 7, 6, blank, blank, something like that. And each column represents individual movies, M1, M2, M3, and M4. And each row represents different users, user 1, user 2. So this is what a matrix looks like. And what is this blank thing? If you see, user 1 has rated movie 1 10 points. 10 out of 10. It's a perfect movie, right? User 1, the same user has rated movie 2 8 and movie 4 8. Now you need to calculate, right? This blank represents that he has not rated that movie, right? If the user is a male, he has not rated that movie. So how are you gonna predict that? What we will do is that we put SVD on this matrix, right? We will get a prediction value, let's say 7. And let here for user 2, let's say we got predicted value as 8 and 9. So what we will do is that first of all we will recommend user 2 with movie 4, then movie 2. And for user 1 there is only one missing, so we will recommend that movie to him based on the rating. That's what we do. So let's say a user in this matrix, user 2 has not watched 2 movies. So from the predicted value, the highest number which we get, you can see movie 4 got the highest number, so we will give that movie first as a recommendation because it has high predicted value. when compared to another blank, which is 8. Yes, it is the second highest. So we'll give that second highest predicted value to user. So this is the problem statement. The main problem statement is that user has watched something, right? User has not watched something, and for the thing which he hasn't watched, he did not rated that. Why? Because he did not watched it, right? Now our job of SVD, like while implementing SVD, is that to find the blank values, to predict the blank values, and among the predicted values we got, we will recommend the highest predicted value first to user, and then second highest, and then third highest. Like this we move through the matrix. Okay, this is the thing we need to find, and this is the problem statement of this entire lecture. If you're clear, then I'll move to another thing. Okay, now uh, let's talk about the method. In this only we have understood how a matrix looks like, and like what are the things involved in this. Our goal is to find this empty bracket. Okay, now the method is that we will take our matrix, right? And for the given matrix we will put SVD, and while putting SVD, if you remember, in previous class we got sigma, right? And whatever the sigma value we get, like sigma 1, sigma 2, sigma 3, these are in descending order, and the sigma 1 represents the highest number of pattern, sigma 2 represents the second highest number of pattern, and sigma 3 represents the least, like sort of patterns, least important patterns in the given matrix. So what we do is that we remove this least thing, because this is insignificant. I'll show you how much insignificant it is. How do we calculate, how can we tell that sigma 3 is insignificant, it doesn't matter? How do we prove that? I'll show you, but this is what we do. We only consider top k, which has the highest significance, and from this top k we will build our new matrix, which is u of k cross sigma of k cross vt of k. So this matrix, whatever the matrix we get, right, this will have all the values with no blanks. In this given matrix, after applying SVD, we call this method as truncation, or you can say truncate of the given matrix. We are removing unnecessary stuff. Okay, remember the terminology. So after truncating the matrix, the resultant we get, right, this resultant is the most important resultant, because in original matrix there are some blank values, right? And blank values are the worst thing that is possible. So when you apply SVD, you will get a new matrix, and that matrix is your new Netflix table, and that matrix will have values with no blanks. There will be no blanks in it. So what we will do is that we will recommend users. We will recommend users movies based on the highest predicted value for them. Based on the highest predicted value for them. Okay, so this is the methodology that we are going to use. Okay, got it. Now let's talk about how we are going to do, and what our matrix looks like. If you are clear with problem statement and the method which we are going to use, we are going to use a method called as truncation, which is really useful, because if you don't truncate matrix, if you take all sigmas and combine together, then according to the rule of SVD, you will get the matrix back, which will have this blanks. So that is why we truncate it to get a new predicted matrix, the matrix which has predictions in it. Okay, now let's move ahead and talk about how are we going to use it, how are we going to implement the concept. So talking about how, right, we have understood problem statement. Now we are going to understood how we are going to implement SVD on the given matrix. So the first and foremost thing is to understand how our matrix looks like. And in my notebook, I have taken an example. So let me quickly see that example as well. In my notebook, I have that little example. So I'll take that. I have a matrix. Let's say I have movies like Inception. I'm taking example which I have written because it is easy to solve numericals, right? So let's say Titanic and Avengers and Batman, right? Batman has to be there, and you can take users as user A, user B, user C, user D. I'm taking just alphabeticals. You can put names as there as well. It doesn't matter. Now I'm gonna put some values like 5, 4, blank, 1. After that 4, blank, blank, and 1. After that 1, 1, 5, 4. After that 5, 5, 1, 0. This is the example which I have taken in my book. Now let me write it here. Let me write it here. This is the, I'm repeating the problem statement again, but our job, I'm writing it here. Our control C. Okay. So our job is to find the blank values. That is the main job that we have to do. The blank values and recommend the movies to our users to our users based on the predicted values, based based on the predicted values. That is our main goal. This is our problem statement. I want you to remember this problem statement in all the like 1 hour lecture, in this entire 1 hour. So our main goal is to find this blank values. So what we're gonna do, what is the problem, what is the problem to implement SVD? There is a problem, right? In there is a problem in matrix n, right? What is this problem? um what are we gonna do? If you remember, if we have a matrix A and to apply SVD, there are three blocks, right? U, sigma, V of T, nothing but eigenvector transpose. Now if you take V is the first thing that we generally find. So if you take V, for V, we need to first of all find the square matrix for n, which is the square matrix. Here for square matrix, the value would be n of t, if I'm not wrong. Now if they are blank, if these values are blank, then how are you going to find eigen-decomposition? And here again we have the problem of eigen-decomposition. You cannot apply eigen-decomposition if the values are null. If you don't have values at all, you need values no matter what. So if you cannot find this blank values, then you cannot find V. If you cannot find V, then there is no way of looking for sigma or U. You cannot find that. Does that mean we can't find our SVD, which is A? Can't we apply this formula? We can. So what we do is that to tackle with blanks, to tackle with this blanks, we use like different researchers, different organizations use different methodologies. But for our case, to make things simple, we replace that with average. We replace the blanks with that particular column average. Okay, so what we will do is that I'll write it here. How many movies we have? Inception, Titanic, and Avengers, right? So what I'll do is that first of all, I'll calculate the average of all movies. So I'll write it here. It will give me average of inception is equals to 5 plus 4, 5 plus 4 plus 1 plus 5. And how many movies I have? 1, 2, 3, 4, right? Divided by 4. Tell me what is the value and um, average of like now Titanic. Titanic is equals to 4 plus we will leave blank. We'll leave for now blank 1 plus 5 divided by 3. It will give you one value. Average of Avengers is equals to 5 plus 4, 5 plus 1. Okay, sorry, my bad. 5 plus 1, I believe. Yep, 5 plus 1. So it will be 5 plus 1 only. So 5 plus 1 divided by 2. So this should give you a value, and similarly, average of average of like Batman. Batman would be 1 plus 1, 1 plus 1 plus 4 divided by 3. So calculate the averages. You'll get some value like this will give 10, 10 plus 1, it will give be 15 divided by 4. And this will give 5 plus 5, 10, 10 divided by 3. It will give you some value. Are we sure this is 5 comma 1? I think we are sure. Like this is the matrix we got. Yep, I'm sure. Yep. So 5 plus 1 will be 6 divided by 2, and this will be as well like 6 divided by 3. So it will be 2, 3, and this is 3.33, and it will be like 4 3 12, 12 3 point. Let me calculate in phone directly. Of course, I don't want to miss decimals as well. So okay, 15 divided by 4, 3.75. Okay, so we got the averages. Now after getting averages, this is our step 2.1, right? After getting averages, put the averages into our blanks, inside our blanks. So we have a matrix, and our new matrix would be like, let me write it down here: 5, 4. This is Inception, Titanic, Avengers, Batman, right? User 1, user 2, user 3, user 4. Now we'll put the we if you remember, we don't have the value for Avengers here, so we'll put the average of the Avengers. So 3, right? So 3, and Batman here is 1, and then 4. Here we had 0, right? So what is the average of Titanic? 3.3, right? After that, again, Avengers average. So 3 and 1 again. After that, 1, 1, 5, 4, and then we had 5, 5, 1, and lastly, Batman averages 2. So we'll have 2. Okay. Yep. So this is our newly constructed matrix. This will be our matrix. Now, if you see here, this was our blank, this was our blank, this was our blank, and this was our blank. Okay. Now, like if you remember, we had blanks, and we replaced this blanks with averages. Now, I want you to look at it. This is our like very basic prediction, right? Very basic predictions of what value should be there in blanks, right? Now what we do is that with our basic human prediction, we give this matrix, this new n, right, with new average n to SVD, and SVD will do different things, and it will give us output, right? This is one method. Now like I want you to, before we apply SVD, there is one more step that we have to do, and that step is important step when it comes to computers. Okay, so to understand that step, we need to go back to PCA. So in PCA, what we did, we had set of points, and that set of points used to form a cluster, right? And what did I tell you there? That the location of the point does not matter at all. What matters is the overall cloud that point is forming, that given set of points are forming, right? That is the most important thing. Now, uh, similarly, in here, it does not matter what number you have. What matters is if you try to put this matrix in that particular dimension, then you will also get a cloud. It is important for SVD as well, that what is this cloud, what is the shape of the cloud. It does not matter like you are recentering it, you are like giving it back, putting it back, it doesn't matter. What matters is the cloud. And in PCA, what we do is that we take this cloud, center it towards origin. Similarly, we take this matrix, we center it towards origin as well. How do we do that? This is our step 2.2. So before directly going to SVD, we take this average matrix, we recenter it. So this is our step 2.2. How do we recenter? Calculate average. Calculate average of each movie. Then subtract it with each unit, each cell. Subtract the average with each cell. This is how we will recenter the given matrix. So let's find the average of inception now. Average of inception is equals to 5 plus 4 plus 1 plus 5 divided by, how many points are there? 4 divided by 4. This will give us 10 and 1. Again, the same thing will give like what? What is 3.75? So it will give me the same thing. Now we'll calculate the average of Titanic. Average of Titanic is equals to 4 plus 3.3, 3 plus 1 plus 5. I'm taking numericals because when we take example, right, it will become easy how the algorithm is moving. If I talk just randomly, okay, do this, do this, do this, we can cover it in less time, but it will end up having a lot of doubts among you guys. So that is why I'm doing this divided by 4. So this will give me, let me calculate it right away, 4 plus 3.33 plus 1 plus 5 divided by 4. So 3.33, 2.25, it doesn't matter, let's take two decimals only. Average of Avengers is equals to 3 plus 3 plus 5 plus 1 divided by 4. So it will give us 3 plus 3 plus 5 plus 1 divided by 3. So it will give us 4. Okay, and are we going in a right direction? I think so, we are going in a right direction. Then average of Batman is equals to 1 plus 1 plus 4 plus 2 divided by 8 divided by 4. It will give us 2. Okay, divided by 4, it will give us 2. Yep, we got the averages. Please cross verify if I made any sort of mistake in calculations. Now after calculating it, we will calculate the recentered matrix now. So our recentered matrix would be n recentered is equals to 5 minus 3.75, 4 minus 3.75, 1 minus 3.75, 5 minus 3.75. Similarly, 4 minus 3.33, 3.33 minus 3.33, 25. I'm taking it as a number, but 0, right? It doesn't matter, but it's all right. And 1 minus 3.33, 5 minus 3.33. Okay, now 3 minus Avengers, 4 minus 4, 3 minus 4, 5 minus 4, and 1 minus 4. And here 1 minus 2, 1 minus 2, 4 minus 2, 2 minus 2. So this is our recentered matrix. Now let me quickly find the values as well, because it's going to be a bit calculation, but it's all right. It's all right. So 5 minus 3.75, 5 minus 3.75, 1.25. So 1.25, 4 minus 3.75, 0.25, 1 minus 3.75, 0.625, 5 minus 3.75, 1 minus 2.5, okay, and 4 minus 3.33, 0.67, and 3.33 minus 3.3325 will be like it's near to 0. It's good to keep 0 here. And 1 minus 3.33 minus 2.33, and 5 minus 3.33, 1.67. I know it's gonna be like it's going a little bit slow, but it's all right. Like calculations are important. 1 and minus 3. This will give us minus 1, 2, 0. So this is our recentered matrix, right? This is our recentered matrix. Now, what we will do is that for this given matrix, we will find n recentered and n recentered t. And after finding it, we will find the v of this given eigenvectors of the given matrix, and along with it, we'll find the lambda as well. So, how many? We'll see. We'll see. For now, what we'll do is that I'll take the screenshot of this matrix. I'll give it to ChatGPT and I'll ask it to give me V, right? The eigenvectors and eigenvalues for the given matrix because I don't want to do a lot of calculations. So I'll just take a screenshot of this. I'll take screenshot and sorry, put it here, ChatGPT. Take the image, put it here. Okay, so first find C first find C, which is n recentered n multiplied by n of transpose, right? First we are telling it to find C, then find for C find eigenvalues and eigenvectors. Okay, so let's hope for the best. We'll not get any imaginary numbers or complex numbers in between because I haven't checked it. I just had example. I just wrote it in my notebook. So let's hope for the best. And once we get eigenvalues and eigenvectors, we can find sigma, and then I can tell you like how are we going to truncate the values. So we have yay, I think it got all the metrics correct. Yep. So it got C. Yep, we got 4. Remember, like this is the thing, right? If I try to do it manually, then there are 4 columns. It means 4 vectors, and I'll get the equation in power 4. And the equation lambda to the power of 4 something, right? It's hard to find solutions for higher powers. For quadratic we can do, then for that power 4 I need to divide it into like 2 segments, power 2 power 2, and for this again find roots, so it'll be a long calculation. That's why I have used GPT here. So we got our lambdas. Let me write it here. Okay, we got our lambdas as, let me take a screenshot and paste it in our, wait 1 second. Okay, let me put it here. Okay, we got our lambdas. Let me, okay. We can take doubts at the end of the session, it's all right. Okay, now we got lambdas and we got v1, v2, v3. So our v would be this. For the eigenvectors are this. So I'll copy this as well, our eigenvectors, and put it here. Okay, let's move on. So we got our vectors as v is equals to v1, v2, v3, and v4, right? So just put the values here. So we'll get our matrix as minus 0.27, minus 0.57, 0.69, 0.36, and this will be minus 0.5, 0.33, and 0.42, and minus 0.62. Okay, now this will be minus 0.51, 0.51, 0.09, 0.68, and finally we have our final vector 0.61, 0.53, and so we got our vectors, right? This is our eigenvectors. Now you can find the transpose as well. This will give us minus 0.27, minus 0.57, 0.69, 0.36. We'll not take this entire matrix because we'll only take few. Okay, it doesn't matter, but I'm just taking for your reference. So minus 0.5, minus 0.33, 0.42, minus 0.62, and minus 0.51, 0.51, minus 0.09, and 0.68. This will be 0.61, 0.53, minus 0.57, and 0.12. Okay, so we got our v of t. Now it's time to find our lambda. Lambda, we got lambda as this, right? So from this we can find our sigma 1. Sigma 1 is equals to root of lambda 1, which will be equals to root of 22.23. Very huge calculations. Root of 5, 9, and sigma 3 is equals to root of 1, 6. Sigma 4 is equals to root of 0.48. I'll paste the values as well. Now okay, so give me let's find u, like, because we know the formula of u, like u is equals to u of 1 will get 4 u's. Remember, 4 u's is equals to a v1 divided by sigma 1. u2 is equals to a v2 divided by sigma 2. Here a is our recentered Netflix matrix. u3 is equals to a v3 divided by lambda 3. u4 is equals to a v4 divided by lambda 4. So you can find u and singular values. So I'll just ask, give me singular values, which are our sigma, and give me use as well, use of our SVD. It is computing. Okay, we got our sigmas. Let me put it here. Okay, we can let me put it here. Little bit, just compress it a bit. Okay, so we got our sigmas. Now, along with sigmas, we got our u's as well. So u1, u2, u3, and this is our final u. So let me just copy all this for reference, but first u is this. So let me put u here. Yep. Okay. So we got our sigma, we got our u, and in one place, let me put all of it. So I'll just take all SVD. So 1 second, just give me 1 minute. So finally SVD will look something like this. Okay. Now this is what I'm telling. So if you take and all this and put it, let me put this a little bit aside. Okay. So what I'm trying to do is that here you got your SVDs, right? You got your SVDs, right? This is your sigma, this is your U, and this is your V of T. You got your singular value decomposition. Now, if you try to put that in the formula, you'll get the same recentered matrix. That is not what we wanted. What we want is that we want to take the most impactful thing, and from or you can say with respect to most impactful thing, we will take only that particular thing, and from the most recurring pattern, whatever the metrics that we will get, right, a of k, that a of k is the most important thing. Okay, so you can write a of k is equals to u of k multiplied by sigma of k multiplied by vt of k. So this is the thing. Okay, this is the formula. This is the important formula that we are going to use when it comes to real-time applications. Now, how much you're gonna take? Like how many top k elements you are going to take? If there are 4 elements, I would say take maximum 2 or 3. If you take all 4, then you will get the original matrix. You don't want that. You want 2 to 3. So you will take 2 or 3. Okay, now you can calculate like how much weightage it is. For example, if I take only top k is equals to 2, then it means that I'll take only sigma is equals to sigma 1 and sigma 2, and I will take u is equals to u1 u2. I'll take v is equals to v1 v2. Okay, this is what I'm gonna do, right? I'll take only this, and from this as well I'll take e of k, and this will be my new predicted matrix. I'll show you, but for now just assume that I have taken top k. So you can see in this has the most highest values, and this is second highest, this is third highest, and this is fourth highest. So what we can do is that you can calculate how much weightage it does calculate. So 4.71 you can calculate like this: 4.71 square 2.34 square divided by 4.71 square plus 2.34 square plus 1.26 square plus 0.69 square. You will get the answer in percentage. And whatever the, if you got 77, then it tells you that if you take these two, then these two only will have 77. If you get 84, this means that this two, lambda 1 and lambda 2, is efficient to tell you 84% of about the data, right? It tells you 84% patterns associated in the given data. It tells you complete 84% image of the given entire data. I hope you got the point. It does hold 84% weightage. You can calculate it and tell me like how much weightage it does have, but it does not important. What I'm doing is that I know that this two has the most weightage, so I'm taking these two. So I'll take top k is equals to 2, top k is equals to 2, and with respect to that I'll calculate my u of k, my sigma of k, and v of k. Okay, and when I do that I'll get a new a of k, and this will be my new table, new matrix, which will have the predicted values. Simple. So what I'll do is that I'll go and tell to ChatGPT that take top k is equals to 2 and give me predicted values. So what I will do is that I will take only top k is equals to 2, and you can see all other things will become 0, and u of 2 sufficient, my u will become this, and my vt will become this. We'll eliminate last two vectors, and then you will get the after multiplication whatever the matrix you get, right? This is the matrix you get. So our final matrix would be this. Okay, let me put it here. So for the given matrix, right? Okay, so what was our original matrix? Our original matrix was, where is it? Let me go a bit up. Yep, this was our original matrix. Yep, this was our original matrix. Now we got the predicted matrix. Generally, in real world cases, we don't get negative values because negative means it doesn't make sense, right? So for our numericals, we have taken a random example. That's why it has given like negative values. But if you observe the pattern, this is our, let me start writing, user A, user B, user C, user D, and Inception, right? Inception, Titanic, and Avengers, Batman. Okay, so the numbers remain the same. Like, let me see the example that this tells you that for user A, the highest matrix is Inception. So Inception will come first, then sorry, Titanic. Titanic will come first, then Inception, then uh, Batman, then Avengers. Okay, so uh, let me tell you this that for user B, right, there were two blanks, if I'm not wrong, this and this. So what we will do is that first of all, because there were two blanks, because there were two movies which he has not seen, that is why we have, like, we will recommend Titanic first, then Avengers, because we got the ratings like this. Okay, so this is the example. I hope you got the overall like concept of how do we calculate. Numericals might like give you little bit up and down. It does not matter. I might have made few mistakes in calculation, and like numericals and calculation does not matter because most of it is done by computers. The reason why I have taken numericals is that it's easy to go with numericals and understand then just let us. So this is it. We got, like, our goal was to find the holes, the blank values, and we found the blank values. This is the new predicted matrix. So what we will do is that for user B, the reason why he got Titanic high is because with respect to the pattern, with respect to user A, C, D, they tend to like the Titanic movie more. And also, right, with like if you see, like, before, in first case, in zeroth condition, right, user B has watched only these two movies, right? He has watched Inception and Batman. So we saw the pattern of Inception among all these users, the pattern of Batman among all these users, and from this users you can see that the people, like, here user D has liked it more, user A has liked it more, and similarly, for them, their favorite is Batman, like Inception as well. See, 0.91, 1.64. So that is why from others user, because they liked Inception and at the same time they tend to like Titanic, but B has not seen Titanic. But the user who has seen similar movies to B are, like, they are like moving towards a prediction of liking Titanic. That's why we are showing Titanic to B, because the people who have watched similar movies like B are, like, like, they have a higher probability that they are going to like Titanic. That's why we are showing them. They have liked Titanic. The users who have similar taste to B has already liked Titanic. That is why we are showing Titanic to him first. So this is it. This is the concept. Okay. Now, shall we code it? I have the code directly itself. I can explain you right away. The first and foremost thing is we are, like, implementing uh NumPy, because implementation of two-dimensional arrays, because matrix is a two dimension, and calculating all this is done by NumPy. So first and foremost thing is implementation. Now the second thing is I have implemented a two-dimensional array. And here this line d type enables the decimal values as well. Okay, now what I did is I have given values like users Alice, Bob, Carla, like this is given me by GPT. So ABC, instead of ABC users, it has given me names. Now it gave me movies as well: Inception, Titanic, Avengers. Okay, now what is this line? What does this line represents? Okay, so let me tell you this. We to understand code, we need to go back to our example. So here we had blanks, but in code we cannot represent blanks. Okay, so what we are doing is that we are segregating which is a real number, which is not a real number. Okay, so here let me draw here. So we got this, right? We have this matrix which is our NP matrix R. Okay, so R is equals to 5 4 0 1 4 0 0 1 1 1 5 4 5 5 5 1 0, right? We got R. Now what is this mask, this variable mask? This variable mask is a two-dimensional array which holds Boolean values. So I will hold mask is equals to true, true, and whenever we get 0, then in that place we will put false, because 0 represents a blank value. We cannot remember, whenever we are implementing arrays, right? We cannot leave blank. So to tackle that problem, we are putting 0 and we are building a Boolean array, and Boolean array will tell us that whether it's an actual number or a blank. If it is false, then it means that there is a blank value there. Okay, so true, true, false, false, true, and uh, true, 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 and false. So this is how we do. Okay, now after that, again, like we are like filling the values. We are like traversing rows, right? After traversing, we are filling it, right? We are filling it with the average. That is what we are doing in the step 2, right? If you see here, the first 2.1 step is take the average and fill it. And this lines is basically what they're doing is that they're filling the columns, right? The values, the blank values with the average. This is what these lines are doing. Now, after this, we are recentering the given matrix, right? We have two-dimensional matrix, which has averages, which has original matrices. So we got the matrix. Now, we need to recenter it, right, to 0. Why? Because it makes our calculations easy. Okay, so it makes computations a bit easier. So we are recentering the given data, then calculating our q singular value v of t, right? Basically calculating our SVD on the recentered matrix. Okay, now after that, like we are rounding this, like this line represents what we are doing on singular values. You can see we got like a lot of decimals as well. We don't want that, so we are rounding that up to 3 decimals. Okay, now after finding our matrix, we got complete sigma, complete u, complete v, right? Now the thing is that if you put complete sigma, complete values, you will get directly this thing, but we don't want that. So we are going to take top k elements. So we are representing k. Similarly, according to k value, we are taking u of k, which is like u1, u2, and s of k, which is sigma 1, sigma 2 only, and v of k, which is vector 1, vector 2, two rows, that's it. Now after this, we are reconstructing our matrix, right? We are reconstructing this matrix. this matrix we are getting here, right? After that, I made a function which calls all this and blah blah blah. Then we are like recommending what was the recommendation for Bob and all. That's what we are doing, and we are capturing the variance of the data. Variance, I have told you, right? To calculate how much variance the given values has, the given value k has, you can take the square, this one here, where is it? Yeah, take the square and divide by total number. It will give you how much variance this particular k is holding. So yep, and yeah, that's pretty much it. First of all, I'm printing the singular values, then I'm recommending the movie. You can see for Bob, the recommendation for our example, the recommendation is suggesting that Avengers is the best movie because it has the highest value. Okay, and the only top, when you take top two, you can see that top k nodes, which is only two, sigma 1 and sigma 2, is capturing 88.4% of data. Okay, now predicted rating for each and every user, they had some blanks, right? So it is telling that for Alice, the like most predicted, the recommendation is Avengers. For Bob, the recommendation is Titanic. For like again Bob, two are like highest values, new predictions I'm telling, like blanks. Okay, so then Avengers, Inception, Notebook. This is what our example is, and I hope you got the concept is the main thing. And this code is very simple, like it has only few lines, and you might lines because I sorry, yep, because I try to explain everything in detail. That's why I have written in an open fashion, but hardly will be 10-15 lines if you try to compress everything in once. So this is the prediction of SVD, and remember, here we have taken the average. Okay, we have taken the average, but when you take production level applications, if they are using SVD for their recommendation systems, they use something more than average, and that can be anything, right? We don't know how they work and all, but for our case, we have taken average because it's simpler, easy to understand, and we are just starting out. We are not expert in ML. That's why average is the best thing. Okay, so let me pin for myself. Yep, so I hope like you have understood how SVD works and all. And in the next lecture, we are going to start with calculus. Till now, we have completed most of linear algebra needed for understanding AI, for the math of AI.